In our arithmetic chapter, this is the first video on fractions, where we're just going to introduce fractions and some definitions and talk about how to simplify. So if you would look at the top of your notes, there's a few definitions, a few words you need to be familiar with. A fraction is just a number in the form of a over b, where a and b are integers and b is not 0. B can't be 0 because remember, any number over 0 is undefined, so it would be an undefined fraction. A proper fraction is a fraction whose numerator, so the top, is less than the denominator, like 3/4, 1/7. An improper fraction is a fraction whose numerator is greater than or equal to the denominator. So 7/5, 4/3, or 6/6. It can be the same. You can have the same in the numerator and denominator. A mixed number is a number made up of a whole number part and a fraction, like 1 2/3. That's a mixed number. So looking at fractions, we have our a over b. This is called the fraction bar right there. That's the fraction bar. And the fraction bar can be read or mean several things. So let's take the example of 3 over 8. This bar can mean out of. So 3 out of 8 people made an A on the test. Okay. It can mean of. You don't see that as much. 3 of 8. And it's just not usually the way we say it. But most frequently, it means divided by. 3 divided by 8. All right, we're going to look at just a couple shadings just to make sure that, again, you have the basics here of fractions. Try to fit this all on the page. It's kind of running over a little bit. I'll move it back and forth. It says shade the indicated amount. We want to shade 3 out of the 4. 1, 2, 3, 4. To shade 3, we would shade like that. That's 3 out of the 4. The next one is 1 3/4. This one means 1 whole. So 1 whole, the whole thing, and then 3/4 more. The next one is 1 3/8. Again, the 1 means 1 whole. So I shade the whole first circle, and then I shade 1, 2, 3 of the 1, 2, 3, 4, 5, 6, 7, 8. So this is the 1, this is the 3/8. The next question says, what fraction of each figure is shaded and unshaded? The shaded region here is 1, 2, 3, 4, 5 out of 6, 7, 8. So 5 out of 8. The unshaded region is 3 out of 8. And notice that if I added them together, it would give me 8 out of 8. Here, the shaded region, you got to be careful with these. These two rectangles are divided into 1, 2, 3, 4, 5, 6, 7, 8s. So this is all about 8s. I know there are 16 of them, but each piece is an 8th. So what's shaded is 8, 9, 10, 11, 12, 13, 14, 15 8s. Or another way to say that is 1 whole and 7 8s more, but they are 8s and not 16s, so don't get confused. Unshaded is just 1/8. All right, let's look at the next page. Here it says what fraction are shaded. Again, these are divided into fourths. I realize that altogether there are 12 fourths, but they're still fourths. This is 1/4, 1/4, 1/4, 1/4, etc. So what's shaded is 4, 5, 6, 7, 8, 9, 10, 11 fourths. Or another way to say that is 1, 2, and 3/4. So 2 and 3/4. Unshaded is 1/4. One of the things that students often have trouble with is plotting fractions on a number line. So let's take a look at the number line that we have. It goes from -1 all the way over to 1. Let me see if I can get this whole thing in here at once. There we go. -1 to 1, 0 in the beginning is in the middle. And so what we need to do before we start locating these points is we need to label our number line. So if this is a 1, I know that it's 1, 2, 3, 4, 5, 6, 7, 8 jumps to 1. So 1, 2, 3, 4 is halfway. So that's 1/2. It also happens to be 4 of the 8s because there are 8 jumps from 0 to 1. On this side, it's the same way, 1, 2, 3, 4, but it's -1/2 or -4/8. Now, in between, we're going to do the positive side and then just mirror that on the negative side. In between, if you talk about these as each being 8s, 1, 2, 3, 4 8s. So halfway in between that, I have 2 8s. And another way to think of that is, let me use a different color, would be 1, 2, 3, 4ths. Those are also fourths. So 2 8s and 1/4 are the same thing. This is 1/8. So I've got 1/8, 2 8s, 3 8s, 4 8s or 1/2. It's also 2/4, so it has a lot of names. Then we have 5 8s, 6 8s, which is also 3/4, 7 8s, and then 8 8s or 1 whole or 4/4. You can call it that. That label went off a little bit. On this side, I know I've got -1/8, -2 8s, -3 8s, -4 8s, -5 8s, -6 8s, -7 8s, and -8 8s. Now in a different color, let's label them as if they were fourths. That would be 1, 2, 3, 4 equal jumps. So -2 8s is the same thing as -1/4. This is the same thing as -2/4, -4 8s, -1/2. It has a lot of names. This is the same as -3/4. So you always want to label your number line first. Now to locate, we probably have everything already marked. 3/4 in the positive direction, we know it's right here. We already have it labeled. It's right there. So this is A. It's the same thing as 6 8s. -1/2, we have it right here. So this is B. And -1/4 we have right here. So this is C. So once it's labeled, it's much easier to locate places on that number line. All right, let's look at writing equivalent fractions. We just did that. When you give different names for the same location on a number line, those are called equivalent fractions. Now, so that you don't have to always put them on the number line and count, we need a mathematical way to figure that out. So here's what it says. Write -1/2 as an equivalent fraction with a denominator of 16. So we're going to write -1/2 equals, now we want to have a denominator of 16 right here. And what you do is you say, what do you do to the 2 to get a 16? You multiply it by 8. Therefore, you must multiply the numerator by the same thing, which are negative, and you have an equivalent fraction. We can go in the other direction also. I want to take 12/15 and I want to write it as an equivalent fraction whose denominator is 5. So I'm going to put my 5 there and say, what do I do to 15 to get 5? I divide by 3. Therefore, you have to do the same thing in the numerator, and that gives you 4/5 as an equivalent fraction to 12/15. All right, looking at our next page, it says writing fractions in lowest terms or simplest form of a fraction. So A fraction is in simplest form, or sometimes it's called lowest terms, when the numerator and denominator have no common factors other than 1. Nothing will go into both of them other than 1. So we're going to look at two different ways to approach this using the fraction 12/20ths. So 12/20ths, the easiest way to do it is if you know what the GCF is, the greatest common factor, meaning what's the biggest number that goes into 12 and into 20. In this case, it's 4. So we divide both the numerator by 4 and the denominator by 4, and you have simplified that fraction. Now let's say, though, that you didn't know what the GCF was. So what we're going to do is take the numerator and the denominator, and we're going to create a factor tree for both of those. So 4 times 3, or 2 times 2 times 3. You just keep going till you can't break down any further. 20, we're going to call 4 times 5, which is 2 times 2 times 5. Now watch, I'm going to take 12/20ths, that was my original fraction up there, and I'm going to rewrite it instead as here's my numerator, here's my denominator. So I'm going to write the 12 as 2 times 2 times 3 because that's how it broke down. I'm going to write the 20 as 2 times 2 times 5. And now we're going to cross cancel anything that makes a 1, meaning something over itself. So 2 over 2 makes a 1, 2 over 2 makes a 1, and what is left is 3/5, which is the same thing we got this way. Now obviously it's easier to do it this way if you know the GCF, but there are times when you don't, and so this is a good backup method, is to do the factor trees and then rewrite your fraction showing their prime factored forms and then cross canceling. So let's use this fraction, and I think because you're probably less familiar with the prime factor method, I'm going to do that. So we have a 42, and we have a 66. We'll deal with the x in a minute. This would be 7 times 6, or 7 times 3 times 2. 66, 6 times 11, 2 times 3 times 11. Now I'm going to write 42x over 66, and we're going to change that and rewrite it with these prime factors plus the x. So the numerator is 7 times 3 times 2 times x. The denominator is 2 times 3 times 11, 2 times 3 times 11. Now we can still cross cancel anything over itself. And when I say over, I just mean part in the numerator, part in the denominator. It doesn't have to be directly over. So this 2 and this 2 makes a 1. These 3's make a 1, and you can see that what is left in the numerator is a 7 times an x, and in the denominator it is an 11. So that method works really well. Here, if I do a factor tree for 10, we'll add the negative in a minute. I get 2 times 5, 27. I get 3 times 9. Break down that 9. But now when I write this in its prime factored form, I have negative 2 times 5 over 3 times 3 times 3. Denominator, numerator with the negative added. Is there anything to cross cancel and make a 1? No. So what that told me was that fraction was already in its simplest form. It couldn't be simplified. All right, let's do it again with this one. So we have 6. We know that's 2 times 3. We have 60. We're going to say 6 times 10. But 6 is 2 times 3, and 10 is 2 times 5. So in my numerator, I have 2 times 3 times, now you're going to take that x and write it as x times x. That's what x squared means. Over 2 times 3 times 2 times 5. I need to make this longer. X cubed is x times x times x. Now we can cross cancel any forms of 1. 2 over 2, 3 over 3, x over x, x over x. Those all make ones. And so when you write what's left, everything cross-canceled in the numerator. But remember, they're making ones when you do this cross-canceling. We're just being lazy and not writing them. So what we really have left is a 1 in the numerator, 2 times 5 times x in the denominator. The x that's left has to stay where it remains, in the denominator.